class 11. Now today we are going to learn about the complex number, chapter number 5. So chapter number 4 is removed from the syllabus from this year. So we start today chapter number 5. So complex number. What do you mean by complex number? Complex number. So complex number is if A and B are any two real numbers is of the form a plus ib. Now it is represented by small letter z. So complex number is if A and B are any real number is of the form a plus ib is the complex number. So it is represented by z. So z can be written as z equals to a plus ib, or we can write a plus bi also. So a plus ib, it is the complex number. It is a complex number. So what is a and what is b and what is I? First, so in complex number there are two parts. One is a real part and another is imaginary part. So what is the real part? Real part is A. This is real part, and B is imaginary part. So real part. The real part of complex number. A real part of complex number is REZ. It is represented by REZ. And imaginary part of complex number is imaginary z. So we can say that I equals to a plus ib. Now this is REZ and this is imaginary z. For example, z equals to 2 plus 3i here. Z equals to 2 plus 3i. So here real part of complex number is 2 and imaginary part of complex number is 3. Okay. So we know that this A is real and B is imaginary, but what is I? Now first we must know about the I. What is I? So I is known as iota. It is the solution of any complex number. I is the solution of the complex number. So iota. It is introduced by Eular. One of the first mathematician introduced I. First mathematician. Euler is the first mathematician who introduced I. I is known as iota. Now first we are going to learn about the power of I or power of iota. Power of iota. So complex number is in the form z equals to a plus ib. Here a is real part of complex number and b is imaginary part of complex number. So factor of I is the part of imaginary complex number. Imaginary part of the complex number. Okay, first now we are going to the power of I. power of I, here I is equals to minus root under minus 1. So I is equals to root under minus 1. It is the solution of any complex number. Say, for example, if you have x equals to minus root under 2. So it has no solution because the square of any negative number is not a square. So it is not a solution. For this we need I. For the completion of solution we need I. For how to apply I? So root under minus 2 is minus 1 into root under 2. So x equals to, so root under 2 is there. Now root under minus 1 is I. Now it is the solution. So I is equals to root under minus 1. So I square is root under minus 1 square, it is minus 1. So I to the power 4 is I square whole square. So this equals to 1 square minus 1 square equals to 1. So in general iota is I to the power n. So n is 4m plus r. 4m plus r means n should be greater than 4, because if you divide the n divided by 4, you will get the quotient and the remainder. So in this case, so I equals to I to the power 4m plus r can be written as I to the power 4m into I to the power r. For example, I to the power 39 can be written as I to the power 4. After 4 we will write m, it is 9, because 4 into 9 is 36, into I to the power r is I to the power, now remainder is 3. So if we divide 39 by 4, you will get the remainder is 3 and the quotient is 9. Now divisor is 4, quotient is 9. So this equals to, so I to the power 4 is 1. So we can write here 1 whole to the power 9 into I cube. This equals to I to the power 9, 1 to the power 9 is 1 into I cube. So this equals to I cube. So I to the power 39 is I cube. We can take any number. Suppose we have I to the power 49, This can be written as I to the power, first we will write 4. 4 into how much? 4 9 is 36, 4 10 40, 4 11 44, 4 12 48, 4 12 48. Now this is I. 48 plus 1 is 49. So this equals to I to the power 4 is 1 to the power 12 into I. So this equals to I to the power 1 to the power 12 is 1 into I. This equals to I only. So therefore we can write I to the power 49 equals to I. Similarly, we can take another example for power of I. I to the power 19. This equals to First we will write 4 and 4. Then remainder is 3. This equals to 4 for the 16 plus 3 is 19. So I to the power 4 is 1. 1 to the power 4 into I to the power 3. So this equals to 1 to the power 4 is 1, 1 into I cube is I cube. So therefore I to the power 19 equals to I to the power 3. The value of I to the power 19 is I to the power 3. So this part can be break. How? I square into I square into I is I cube. So I square is minus 1. So I is I. So this equals to minus I. So further we will write I to the power 19 equals to minus I. Similarly here also no. For I to the power 39. For I to the power 39 is also I cube. So I cube can be written as I square into I. So I square is minus 1 into I. This is equals to minus I. Further we have to break I to the power 3 into 2 part. So this is the power of I. These are the power of I. So we know that the complex number is z equals to ib. So z equals to a plus ib. Not z equals to ib, sorry. Z equals to a plus ib. So a plus ib, a is a real part and b is imaginary part. This is re z and this is imaginary z. So now what is I? I is the solution. I is the solution of complex number. Okay, this was for today. So we will be doing in details from next class. Thank you.